Hi friends, welcome to my channel. Let's have a look at problem 997. Find the turn judge. So in this video, we're going to practice some basic concepts in graph theory, the in degree and the out degree. So this problem statement is the following. So in a turn, there are n people labeled from 1 to n. There is a rumor that one of these people is secretly the turn judge. So if the turn judge exists, then the following three assumptions hold. First, the turn judge trusts nobody. Secondly, everybody except the turn judge himself or herself trusts the turn judge. So thirdly, there is exactly one person that satisfies the first two items. So we are given an array called trust, where trust is an array starting from with elements AI and BI, representing that the person labeled AI trusts the person labeled BI. So we are going to return the label of the turn judge if the turn judge exists, and otherwise we're going to return -1. So here are some examples. So in example 2, we see that 3 trust nobody else, but all other people 1, 2 trust 3. So 3 is a turn judge. So the constraint is basically on the number of people, so which is bounded above by 1000, and also the length of the trust is actually bounded above by 10 to the power 4. So all the pairs of the trust are unique, and the last two items in the constraints are actually consistency assumptions. So with that said, actually let's do some practice or briefing. So here basically we can solve this problem using some elementary graph concepts called in degree and out degree. So first we can define what's in degree and what's out degree. The in degree of a node V in a graph is defined as the number of direct edges pointing to V. So the out degree of a node V is defined as the number of direct edges starting from V. So these two concepts are actually fundamental or elementary in some sense. So in this problem, if we make a connection, then for n people with one possible judge, the judge is the node V such that its or his or her in degree is n-1 and out degree is 0. So this is actually the connection with the current problem. So other example usage of in degree is the following. For example, in topological sorting, for example, the Kahn's algorithm. So please see the relevant videos in the playlist or channel. For example, the cost schedule problems using Kahn's algorithm. So now let's look at this problem. So the solution to this problem is actually very straightforward. First, we are going to make a dictionary. Let's call it a table. It's going to store the in degree and out degree information for each of the people. So so let's see. Initially, the in degree and out degree for this I is 0 and 0. So this is for I in range, so 1 to n. So we write n plus 1 here. So here the tuple, the array or the list here. So this is nothing but in degree and out degree. Right. So with that said, let's just do a for loop for AB in trust. So this means that there is a direct edge from A towards B. Then we can actually update the in degree of B by 1 and update the out degree of A by 1. So it's table A. So we need to update the out degree for A. That is the second element. So increment by 1. And we need to update the in degree for B. So the in degree is the first element. So we're going to increment by 1. So that way, after this for loop, we get all the effective information in this problem. So next we're going to have a candidate. Let's see, candidate. So we're going to do say I for IV in table items. So we want this V equals this one. So we want the in degree to be n-1 and odd degree to be 0. So this can be a empty list if there is no judge, right? So then we are going to return -1 if not candidate. Otherwise, so we're going to return the corresponding judge in this candidate. So that's the A solution to this problem. So a very direct or brute force solution to this problem. Let's do a special case check. Yeah, it passes example 1. Now let's look at the generic case. Yeah, it passes the generic case. I guess for this problem, so a solution is not a big problem, but it's good to understand the two concepts, the in degree and odd degree, and find applications in other situations or problems. For example, topological sorting in cost scheduling problems. So you are welcome to watch the relevant videos. Thank you very much.